Okay, a definite integral, taking an antiderivative. In this case, we have x to the first power down in the denominator. Now, I know a lot of people want to get started and write that with a negative exponent, but this is kind of our special case where you can't use the power rule in this one. Instead, as you take the antiderivative, we'll bring the 3 along, the constant comes along, but the antiderivative of 1 over x is going to be the natural log of the absolute value of x. And then we're going to evaluate that between 1 and e to the 5th power in this case. All right, I know it takes a little bit of getting used to when you have that x to the first power down in the denominator, but this is that special case. If it was x to any other power in the denominator, you could use negative exponent and then the power rule to take your antiderivative, but just not in this case. All right, so taking our antiderivative, we're done with. Now we need to evaluate this at the bounds of integration. So the first thing we're going to do is go ahead and evaluate it at that upper bound, e to the 5th power, and then we subtract away, and we're going to evaluate it at that lower bound, 1. Now's a nice time to remember that natural log and e to a power are inverse functions. So when you compose together inverse functions, what's going to happen is you get some nice cancellation. Or another way to think about it is, if you plug this in, we're going to be left with whatever our exponent is. So when you compose together natural log and e to a power, you end up with the power. So in this case, it works out to be 5 minus 3 times. Now, this is kind of a special case over here also, where we have natural log of 1. Well, we could actually rewrite 1, strategically if we wanted to, as e to the 0 power. Right? Anything to the 0 power is equal to 1. And now you can see that we again have lined up natural log with an e to a power on the inside, so that second piece there is going to evaluate to be a 0. All right, so in this case we have 3 times 5 makes 15, minus 0, so our final answer is just going to be 15. So I hope this helps out. I know a few special cases showed up in this problem, but you can get through them. Just take your time, keep reviewing over those properties.